So let's begin by understanding the fundamental difference between what a number is and what a numeral is. Before we get into the different kinds of numbers and different aspects of numbers, let's examine the difference between a number and a numeral. A number is essentially a concept, it's an idea, and a numeral is essentially a symbol. So when we say 7, this also contains the idea, the number 7, that is 7 things, 7 cars, 7 bottles, 7 flowers, but it's also a way of writing 7. So when we write 7 like this, it's also a symbol for 7. So that's the difference between a number and a numeral. A number is the concept behind a symbol, and a numeral is essentially the symbol itself, which can have different meanings. So it's also a way, we can say it's a way of writing, a way of representing a number. So that's the difference between a number and a numeral. Now before we jump into place value and other such stuff, it's worthwhile remembering that a number has many aspects to it. For example, a number can be a set of things, or it can be an order of things, or it can simply be a label. So let's start by looking at number from a sets point of view, sets of things. So here we have one set and here we have another set. We have one set of squares and we have another set of triangles. So there are 3 squares in one set and there are 3 triangles in the other set. So if you were to look at what is common in the 2 sets, although they have 2 different items, square is not the same as a triangle and triangle is not the same as a square, but essentially there is something still common about the sets, and that is that it has 3 items, 3 numbers of each item. So in set 1 we have 1, 2, 3 squares, and in set 2 we have 1, 2 and 3 triangles. So although triangle is not the same as square, there is still something common in between these 2 sets, and that is there are 3 items of each. This way of looking at numbers as sets of things, this is essentially what we mean by the cardinal, sorry, I've got the spelling wrong, the cardinal aspect of numbers. But there is more. We also see numbers put things as numbers to put things in order, like a number line, for example, or say page 3 of a book, which comes after page 2 and certainly comes before page 4. On a number line, you can see the number 3 comes before number 4, certainly after number 2, and 10 comes after 9, certainly before 11. So here we are not referring to sets of things, but only one thing which has a specific place in an order. And this is known as the ordinal aspect. The ordinal aspect of numbers. Now if you go back to our sets, the set of triangles and squares, you can see when we order things in a specific way, 1, 2, 3, that's the ordinal way of looking at things. So when a child points to each of these items and starts numbering them, 1, 2, 3, 1 triangle, 2 triangles, 3 triangles, essentially what the child is using is the ordinal way of looking at numbers. The child also needs to understand, now you'll realize that the last ordinal number is also the cardinal number of the set. So if the set had 4 items in it, ordered as 1, 2, 3 and if we had a fourth circle here, a fourth square here, and this was number 4, the last ordinal number, in other words the last number in the order, would also be the cardinal of the set, because now there are 4 things in the set as opposed to 3 things. So that's the relationship between, or that's the way you look at ordinal and the cardinal coming together. And when a child learns or begins to understand that the ordinal, the last number on the ordinal system, is essentially the same as the cardinal number of the set, this can be quite important when the child begins to understand the numbers and the numbering system. And finally, we see numbers as labels. For example, buses, school buses can have numbers, and public buses can have numbers. Now, these don't mean any order. So bus number 11 here doesn't mean that is going to be necessarily followed by bus number 12. Here you have bus number 88, for example. It doesn't mean that the bus after number 88 is going to be 89, or the bus before 88 is going to be 87. They are simply labels. They may signify certain routes to different places. Maybe number 11 goes to a particular place, number 12 goes to some other place. For example, here 88 goes to Camden Town, and number 11 seems to go to Olditch. So they don't represent, they are not collection of things, so they are not sets of things, nor are they an order of things. They are simply labels. And labeling leads to, or when you look at numbers as labels, this is essentially what we call the nominal aspect of numbers. They don't specify any order, they don't specify any sets, they are simply a way of labeling things. Now let's slowly jump into the different kinds of numbers. We begin with understanding what are natural numbers. So when we think of all the numbers we use for counting, let me use another color. When we use all the numbers for counting, a set of say 1 to 100, or 1, 2, 3, and on, these are essentially called natural numbers, all the numbers we usually use for counting. And as we've seen, these numbers certainly can have an ordinal aspect as well as a cardinal aspect. They can be sets of things, they can be an order of things. But how many numbers are there less than 5? If I was to ask you how many numbers are there less than 5, it's an interesting question, because if you consider negative numbers, there are infinite number of numbers that are less than 5. So if you look at the number line, we have 4, 3, 2, 1 and 0 if we were not to include the negative numbers. But if you were to include the negative numbers, you have -1, -2, -5, and this can go on forever. It can go to -1 million, 1 billion, and it never really stops. So there is infinite number of numbers that are less than 5, and similarly there are infinite number of numbers that are greater than 5. So if we consider negative numbers, then there are infinite numbers of numbers. This means that we can extend the number line to include negative numbers. So this expanded set of positive and negative numbers is what we call an integer. An integer. Integers are essentially all the numbers positive as well as negative. So if you take 5, for example, positive 5 is represented on the right side of the number line, and negative 5 is represented on the left side of the number line. Mathematically speaking, -5, the proper name for -5 is negative 5, and this is what we refer to as positive 5. positive and negative. We usually hear people say plus 5 and minus 5, which is actually not correct, because minus is just another word for subtraction, and plus is another word for addition. But coming back to positive and negative numbers, negative integers cannot be understood in the cardinal sense. Can you imagine a set of negative 5 things? Set of negative 5 things? No, that sounds weird. You need to make the connection in the ordinal sense by using a number line. So this is why number lines are important, because it allows children to understand or visualize numbers beyond thinking of sets and orders. Beyond thinking of sets, now you can see orders that are positive orders and negative orders. So this is why a number line is essentially important. So coming back to the first two types of numbers that we talked about, we have natural numbers and integers. Natural numbers are all numbers that we use for counting, the positive numbers, and integers includes all the negative numbers as well. So essentially what we are saying is natural numbers are basically all the positive integers are natural numbers. All the positive integers are natural numbers.